Hello students, in this video I would like to talk about the second type of differential equation. We call it the first order linear differential equation. So let's begin this discussion by simply understanding the definition of the first order linear differential equation, and then we will discuss how to solve problem involving first order linear differential equation in a general sense. Okay, so let's define first order linear DE. Here is the formal definition. The differential equation of the form dy by dx plus some function of x times y equal to another function of x is called a first order linear differential equation. Alright, it's a very simple definition. Dy by dx plus function of x multiplied by y equal to another function of x. Alright, so any differential equation that is in this form, we would like to call it the first order linear differential equation. We have studied initial value problem, so we are interested in its IVP form. So let me give you IVP form as well. It is dy by dx plus function of x times y equal to some function of x with some initial condition given. Alright, so remember, initial value problem is really differential equation with supporting initial data. How initial data is helpful? Initial data will help you finding one particular solution from the infinite family of solution that passes through the point x0, y0, which are really numerical values. Alright, okay, so the question is how to solve first order linear differential equation. As I mentioned, that in this course you are going to study two different type of differential equation. We already discussed separable differential equation in the last video. Now this is the second type of DE that we are going to study. We call it first order linear DE, and we have a general idea to solve it. So here is the general idea. To solve first order linear DE, the process is somewhat lengthy, so I am going to divide this process into few simple steps. Alright, step number 1, write the problem in the standard form. Let me mention here that by standard form I really mean the following. Coefficient of dy by dx term needs to be 1, and then this term must be followed by y to the power 1 term multiplied by function of x. Anything else, anything that is purely related to x, has to be on the right side of your equation. Alright, so this is what I mean by writing problem in the standard form. Okay, dy by dx term must have coefficient 1, and then the second term will be y to the power 1 term. The term that doesn't have y in it must be sitting on the right hand side of your differential equation. Alright, so that's what we mean by writing problem in the standard form. Once you have a problem in the standard form, I want you to compare it with the standard form. When I say standard form, I really mean, this definition. Alright, either initial value problem definition of first order linear DE, or the general definition of first order linear DE. Step 2, compare it with definition and obtain the following. Obtain p of x. I call it coefficient function because it is multiplied by y to the power 1 term. Alright. The right side function g of x, initial x value and initial y value. Okay. So once you write your problem in the standard form, I want you to compare it with the definition or the standard form and extract this information: p of x, g of x, x naught, y naught. As I said, I will call p of x a coefficient function, g of x I'll use the wording right side function. Okay. Alright, once you find this information, in step 3 we will try to use this information. So let's start using this information. Using the coefficient function, I am going to construct a brand new function of x that I am going to use to generate the solution of first order linear DE. Now this function that I am going to construct is called integrating factor. So the third step is compute the integrating factor. In short, I will write I dot f to represent integrating factor. As I said, it's a function of variable x, and this is how you obtain it. Integrating factor can be obtained by simply putting one antiderivative of p of x in the power of e. Alright? So e to the power integral of px dx is going to give you integrating factor. Okay. Alright, once you have integrating factor with you, we can calculate the general solution. Alright, so compute the general solution. Or g dot s. This is how the general solution look like. It's going to be y equal to, what I want you to do is multiply integrating factor with the right side function. Find out one antiderivative of this product with respect to x. Add a constant of integration to it and divide this whole thing by integrating factor. Alright, this formula is a formula to compute the general solution of the first order linear differential equation. So as you see, we have this 4 step out of 5. Write the problem in the standard form, get the information about coefficient function, right side function, x naught, y naught, compute integrating factor using coefficient function by simply getting one antiderivative of p of x with respect to x and put it in the power of e. Compute the general solution by simply integrating product of integrating factor and g of x, add constant of integration to it and divide this sum by integrating factor. And then final step, if you are dealing with initial value problem, then convince yourself that your general solution will have 3 unknowns, x, y and c. If I supply you the value of x and y in terms of number, it is possible to compute c. Alright? And then plugging that particular value of c back in the general solution will give you particular solution that goes through the initial data. Alright? So let's write it down. Use x0 and y0 to compute c. And then compute the particular solution. Alright, so more or less this is the general idea that I would like to use to to obtain the solution of the first order linear differential equation. As I said, this is a step-by-step process that I want you guys to follow. This process is applicable on a very interesting set of problems. Alright, as far as you use the correct integration technique to integrate that product of integrating factor and g of x, should be ending up with the correct answer. Alright. In the next video, I am going to discuss few really interesting type of examples that uses various integration techniques.